15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on another edition of the Space Nuts podcast, episode 192. I think. I can't keep count. Anyway, my name's Andrew Dunkley, your host, and with me as always, Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
We're actually with episode 192. We're approaching my age in episodes numbers, which is
we're halfway there.
Yeah. Excellent.
Sorry
but thank you very much, Andrew. It's always good to talk,
yes,
no matter what episode we're on.
Today we are going to reveal the title of my book.
Oh, yes.
And that's all we're going to do. No, I'll explain it later. It was a complicated process, and I fear that I didn't actually give people enough information to come up with an angle that worked, but that's on me. But a few answers that came through on potential titles sort of got my brain working, and I finally came up with something that my wife approves of. So that is it. That's got to be it. We're also going to talk about the biggest explosion ever seen in the universe, the first extraterrestrial protein found in a meteorite. Earth has a mini-moon. And we've got a couple of questions to answer. One about what damage your eyes might suffer if you watched a catastrophic event in space. I mean, they say don't look at the sun through a telescope, but what about something else? And someone else is wondering about, well, not one thing, a whole bunch of stuff. I think he was sitting on the beach in Byron Bay contemplating, and all this stuff just came out of his brain. So he sent us a note. We'll deal with it for you, Frank. We will answer every single question. Actually, we should probably do episode 193 just based on what Frank wants to know. But we'll get to that. But let's start off, Fred, with the biggest explosion ever seen in the universe. When did this happen?
Quite a while ago, probably. Hang on while I bring my notes up. Here we are. For a start, the event we're looking at took place in a cluster of galaxies, which is 390 million light years away. So that means that what we see, which is itself a relic, what we see actually set off on its journey 390 million years ago, before you and I were born. So it is something that's happened a long way off and a long time ago. But, as you said, it's the biggest explosion ever detected, and certainly ranks with, the sort of supernovae things that we see. We see supernovae, exploding stars. This was something much bigger than that, which came from the bowels of a black hole in the center of the dominant galaxy in the Ophiuchus cluster. And in fact, the cavity that this explosion left in the gas of the galaxy cluster was big enough to hold 15 of our Milky Way galaxies.
Wow!
So
it was super. Knowing the International Astronomical Union, it's probably been called the super duper nova.
At least that. So it might even be super duper hypernova. It's certainly big, and it's an interesting story how astronomers have actually come to this conclusion, because it had a bit of a false start. Back in 2016, astronomers using the Chandra X-ray Observatory, that's a NASA spacecraft, of a similar class to the Hubble telescope, but it's the sort of X-ray equivalent of the Hubble. The Hubble looks at the universe in visible light and ultraviolet light. Chandra looks in X-rays, short wavelength radiation. And it was the X-ray observatory that was used by a group of astronomers to check out this galaxy cluster. And what they found, X-rays look at highly energetic gas in clusters. So you're kind of looking at something very energetic to start with. But they saw that there was a sort of curvature in well, I suppose you could call it a curved edge to one of the gas clouds they were looking at. And when you see when you see something curved like that in space, and we see these commonly in what we call supernova remnants, not super hyper duper nova remnants, but normal supernova remnants, where they basically carve out a cavity within the interstellar medium, the gas surrounds them. So what these guys saw was a curved thing that looked as though it was part of a cavity, but they did a quick calculation to show what kind of energy would have been needed for something to explode to produce a curvature of that size, and all fell about laughing because it was far too big. So they actually ruled out an eruption because the amount of energy would have been so big. There the story rested until more recently, and now the work that's come from the Chandra Observatory has been supplemented. I think there's another X-ray telescope involved as well, but actually it might not have been. Yes, it was actually. There's one of the European spacecraft that was used as well to make these observations. So the space observations were recently supplemented by essentially ground-based radio telescope observations made in India and in Australia, and that's where the story comes really rather close to home, because earlier this week I was actually at the headquarters of the observatory, the Australian observatory that was used to make these observations. It's an instrument called the Murchison Wide Field Array. It's at the Murchison Radio Astronomy Observatory, which is in Western Australia, a very, very radio quiet part of the country. The Murchison Wide Field Array is an instrument consisting of about 4,000 antennas, not very big ones, things that sit still on the ground because you steer it electronically. That telescope, though, is well suited to wide-angle survey work, and it was used alongside the one in India to confirm that when you look at the radio radiation, there has been an explosion of the kind that will be needed to carve out this very large cavity in the gas of the Ophiuchus cluster. There's a lovely quote, actually, from one of the scientists, Maxim Markovich, who's actually at NASA's Goddard Space Flight Center. He said, the radio data fit inside the X-rays like a hand in a glove, which is very nice, confirmation. And basically, he went on to say, this is the clincher that tells us an eruption of unprecedented size occurred here. So what we're seeing now is the aftermath of that. That explosion is thought to be over, or the outburst from the black hole that produced it is thought to be over. And given that there's no sign of activity around from the black hole in the center of the galaxy, in the center of the cluster. And so it's a really nice example of what you can learn by having multi-wavelength observations. In fact, in the press release I've read, there's a quote from a person I was speaking to on Monday at the Murchison Wide Field Array headquarters. This is Melanie Johnson-Hollett, who's the director of that facility. She says, as is often the case in astrophysics, we really need multi-wavelength observations to truly understand the physical processes at work. Having the combined information from X-ray and radio telescopes has revealed this extraordinary source, but more data will be needed to answer the many remaining questions the object poses. And
do we know what exactly it might have been?
I think the speculation is that there is a very large, and I don't know the details of the black hole, but it's a supermassive black hole,
right,
which is in the cluster of galaxies, and it is almost certainly a gobbling up type event involving that black hole that then produced jets of material that in turn pushed this cavity out into the interstellar medium. So, something pretty significant coming from a black hole.
Bringing it back down to Earth, I can see in the story that they suggested that this particular explosion, if you want to sort of miniaturise it into something we can get our heads around, was much the same as the 1980 eruption of Mount St Helens, which basically blew out the side of the mountain and was lateral rather than straight up as volcanoes do. So that's how they're describing this.
Yes, it's a nice analogue that, it's something really that's far more energetic than you would imagine would be possible. I remember that Mount St Helens activity very well. Yeah,
that was horrible because so many people were there to watch it and witness it, thinking they were at a safe distance. But the side of the mountain sort of slid away, and the eruption burst out across the ground, which was horrifying. And the devastation was just unimaginable. It was one of those freaks of nature situations, as was this, I suppose.
That's right.
Yeah, there may be more to learn, but I'm glad it's all calmed down. I'm glad it was so far away.
Even though it's so far away, that's right.
You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Let's take a break from the show and hear a word or two from our sponsor, Grammarly. Now, I have to say I'm a big fan of Grammarly because I've been using it for a few years now. Very helpful for authors, but also really good for everyday life. They've saved me on a few occasions. Particularly with spelling, but also with a few issues that didn't quite make sense. It's built by linguists and language lovers, and Grammarly's writing app finds and corrects hundreds of complex writing errors, so you don't have to do it yourself, word by word, day by day. You can easily copy and paste any English text into Grammarly's online text editor, or just install Grammarly's free browser extension for Chrome, Safari, Firefox, and quite a few others. Grammarly's algorithms flag potential issues in the text and suggest context-specific corrections for grammar, spelling, and vocabulary. Grammarly explains the reasoning behind each correction so you can make an informed decision about whether and how to correct an issue. Grammarly helps you write mistake-free Gmail, Facebook, Twitter, LinkedIn, and nearly anything else you write on the web. For you, the listener of Space Nuts, Grammarly is offering a free download of the Grammarly software. So if you'd like to download Grammarly today, go to getgrammarly.com/spacenuts. Again, that's getgrammarly.com/spacenuts to download Grammarly for free and let them know you came from us. I'll include the link in the show notes as well. And now, back to Space Nuts.
0G, and I feel fine.
Space Nuts.
Now, Fred, I just want to send a little bit of a thank you out to our patrons because they've increased in number in the last week. We've had someone sign up for an outstanding monthly contribution, which is just wonderful. And we've sent him a personal message of thanks. I don't know if he wants his name out there, so I won't embarrass him, but I just want him to know that we are eternally grateful for his gratitude. We're aiming to get 500 patrons. We're at 67 now, which is magnificent. 67 people who think we're worth a couple of bucks a month, Fred. I'm chuffed. I think that's lovely. I'm
astonished.
I'm glad they're enjoying the program and what we have to offer, albeit just a fraction of interest. But no, on a more serious note, it is wonderful that you feel obliged to put something back into our coffers, and we are so very thankful. So if you would like to become a patron, you can do that at patreon.com/spacenuts. All the information you need to know is there. It's not mandatory, and we're not going to send the boys around if you don't. It's just it's an option. And if you think we are worthy, that's fine. If you don't, and that's most of you, that's fine too. Oh, that was terrible. But yeah, thank you very much for your support of the Space Nuts podcast. Now, Fred, moving on to this rather interesting story. We've got a couple of things to knock off in this segment. This is the discovery of the first ever protein found in a meteorite, extraterrestrial protein. That is the key word in this, extraterrestrial. Now, I know what some people might think. I'm sure some of the press went, "Oh, we found aliens," but I suspect it's something else.
Well, it's a pointer to aliens, I guess. It doesn't mean that this is, it's not evidence of alien life of any kind, but it is one further step in the notion that the complex molecules that build up, that make up living organisms, have their origins, may have their origins in space. It's an interesting story, and it's got a little bit of a parallel to what we were just talking about. The fact that something was observed a long time ago, and it's more recently been followed up with other equipment to get a different answer. So it comes about because of analyses of meteorites that are actually in museums. Basically, there were two meteorites involved in this story. Their names are not really important. They're ones that basically were, found. I think one was found in the Middle East somewhere. I'm actually just looking for their names. But as I said, that's not the important bit. The important bit is that some years ago, these meteorites were analysed, and what was found were the complex molecules. They found things like ribose, which is a type of sugar, and it's found in RNA, and amino acids. These are basically the building blocks of proteins. So people knew that already. These molecules had already been found in these meteorites. But what has now happened is that a new superconductor X-ray source has been used. It's a mass spectrometer, a thing that measures the masses of molecules. This is new technology, Andrew, and that's kind of what's pushed this research further forward. And it actually, in fact, it's really interesting because some of the authors of this work are actually connected with the company that builds the equipment rather than academic, an academic university. Although I've got the paper in front of me, and it has actually 1, 2, 3 authors, and I think I think 2 of them are from the commercial companies. I might have that wrong. I should check it more closely. So don't write in if I'm wrong. But the bottom line is,
they will.
Yeah. The bottom line is that with this new equipment, the complex molecules have revealed more details about their nature. There is an independent comment from an astronomer, basically here in Australia. He's a chemist, astronomer. Oh, sorry, might be a she. Yes, it is a she. I beg your pardon. It's the CSIRO here in Australia, and the quotation is, in general, they're taking a meteor that has been preserved by a museum and has been analysed previously, and they're modifying the techniques that they're using in order to be able to detect amino acid inside this meteor, but with a higher signal-to-noise ratio. This is the yardstick by which we judge all our measurements, whether they're astronomical or bits and pieces of meteorites. It's all about the signal-to-noise ratio, and so. What the team found were an amino acid called glycine, and that came in with a stonking great signal that wasn't present in the earlier analysis. But they also found that this glycine had other chemical elements attached to it, iron and lithium, and basically almost in an echo of the incomplete cavity that we were talking about just now in Ophiuchus. What they found was something that completed the picture. They realized that this glycine wasn't just an isolated amino acid; it was actually part of a protein, and which they've given a name. It's hemolythin is what they're calling it. So there's a comment that hemolythin is actually similar to proteins we find here on Earth, but, and this is the clincher to all this, it's the ratio of deuterium to hydrogen, that's heavy hydrogen to hydrogen, that is a ratio that is only found in long period comets. You don't find it in the terrestrial version of these proteins. So this protein has got, the atoms within it are definitely from outer space. And so that's, as I said, it's the clincher.
So bottom line, it's a protein that's associated with what we refer to as a building block of life, and it's come from somewhere else.
That's the bottom line, exactly.
So, as they say, not proof of extraterrestrial creatures, but proof that the building blocks are out there.
Yes, that's right. Yeah, and these are complex building blocks. They're, proteins. As far as life on Earth is concerned, that life basically always involves proteins. So it's a really interesting discovery. The paper that has been written on this, the paper's entitled "Hemolythin, a meteoritic protein containing iron and lithium." I have read the abstract of that. I haven't read the paper. And it's it's fairly complex stuff. My life science skills are pretty basic, I have to say. They're limited to stroking the cat, as you know. That's as much as I know about life sciences. But when you get the drift of it from the abstract in the paper, and that's the bottom line. This is all about the isotopes that have been found and that signature that tells you that this is extraterrestrial.
Wonderful. Wow. Fascinating. Well, little bits and pieces of evidence are starting to build, Fred. It's only a matter of time. Only a matter of time. And we'll be here to tell you about it, even if it takes another 150 years. I hope. Now, while we're talking about meteorites, let's move on to something that's not a meteorite, but I don't know, same dog, different leg action, I suppose, and that's Earth's mini moon. We've got a mini moon at the moment.
We've got a mini moon. That's right. Actually, you're right. That's a good segue because this is, it's a small asteroid, and the boundary between large meteorites and small asteroids is a fairly fuzzy one. This is an object which is in the region of 3 meters in size of a vehicle, a car, probably, which has been detected at the Catalina Sky Survey. So this is basically the Catalina Sky Survey. They have telescopes in Arizona.
They're not getting, it's not a Tesla, is it? They might be getting confused.
That's a really good point. That's on its way to Mars, though. It's not around, a bit around the Earth. So the Catalina Sky Survey has picked up this asteroid, which rejoices in the name of, I've lost its name. Hang on, let me find the note.
2020
it is called
CD3.
That's the one. Yeah. Yes, exactly. 2020 CD3, a very faint object. It's 20th magnitude, which is, as astronomers speak, for something very dim. It's moving, but the discovery, which was made only a week or so ago, Andrew, this is really recent stuff. It is moving in an orbit around our own planet. Yeah. So it's actually a moon.
So it got captured, obviously. It was passing by and went, I need a rest. And that was what happened.
Put its feet up, had a bit of a rest. That's right. So what you can do when you find something like this is essentially analyze the orbit and look at the instabilities in it. And the discoverers are actually fairly clear that this thing has probably been only around for maybe 3 years or so. It's not a long-lived asteroid orbiting the Earth. It's just a temporary visitor.
And the conversation went something like this: Mother Earth was asked by her son, the moon, "Can we keep it, Mummy? Can we keep it?" And she said no, because it ain't going to stay.
That's the bottom line. It ain't going to stay. Maybe even in 3 months or so, it will have gone.
Why will it go? I mean, is it because it's just too far out, or is it gaining momentum? Is that what's happening?
Yeah, so it's the orbital dance of an object like this around the Earth. So it's feeling the pull of the moon, it's feeling the pull of the Earth, and it's feeling the pull of the sun. And those things are all they all come into play as it moves around the Earth to give it a sort of fairly bumpy ride. And I guess what will happen in 3 or 4 months or so, maybe a bit longer, is that it will come to a point where the gravitational attraction of the sun is stronger than the gravitational attraction of the Earth. And basically it will leave the Earth's orbit. It will stop being bound to the Earth. When you've got an object like this, probably, it's been captured as it's bypassed the Earth. It's felt the pull of the Earth, and that's shifted it into an orbit around the Earth. But that's it's a tenuous thing. It's not, it's not a strong attraction binding it there. So it's always on the edge of drifting off somewhere else, and that is what will happen.
So it'll just fling off, or will it be a sort of a ballet removal?
I think it will be more. It'll be more of a clunk, probably. No, I think a ballet is quite a nice way to put it. It will drift away, do a couple of pirouettes, and then disappear once again to be in orbit around the sun, which is kind of where it started from. It would have been a near Earth asteroid. It's so that piece of research is interesting. It's not actually the first asteroid that we've seen that's done this. Another one is. Or was called, well, it still is called that, 2006 RH120. It is, again, an asteroid that was captured by the Earth and basically didn't hang around too long. So this is the same sort of thing.
So this has probably happened umpteen times, and we've just not really
never
known. Too small, too far away. Yeah.
Exactly right. So it's not, it's a phenomenon that almost certainly is pretty routine for the Earth to pick up objects, hang on to them for a while and then lose them. But most of them are just too small, and it's really only now that we've got the technology to see them that we are actually finding these things.
You wait, someone's going to come out and say, well, that's the reason we've had all these droughts and fires. That's what it was, the mini moon. That's what'll happen. Someone will say it. You watch.
Well, you've just said it.
No, I'm just suggesting someone will say it. I'm not making that claim. Okay, enjoy it while you can, but
that's right.
Pretty hard to see. You're listening
Having two moons is good.
Having 2 moons is pretty cool. It's about time.
Yeah.
You're listening to Space Nuts, Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we keep bringing this up every week, but our YouTube numbers are escalating at a great rate of knots. We have 1,120 YouTube followers now on the Space Nuts YouTube channel, which is rather fantastic. It's sort of putting pressure on us to do a vlog or a video episode.
Well, we'll get round to it.
Something like that. I wouldn't want them to record what we're doing now, which we could do, but it would be, at least at my end, fairly ugly, especially this time of the day. But thank you for following us on YouTube. You can do the same, youtube.com/C for Charlie/Space Nuts should find us. And you simply subscribe and voila, all done. Now, Fred, let's move on to some cards and letters, shall we? I'm going to ruffle around. Yes. I'm going to ruffle around in
the bag. Yeah.
See what I can find. You hearing that?
I can see it as well.
Oh, yes.
There's plenty of stuff in there.
There's plenty in there. And our first note comes from Steve in British Columbia. Hi, Fred and Andrew. My 8-inch backyard telescope is festooned with warnings against pointing it at the sun because of the concentrated solar energy that would result or could easily destroy my eyesight. I have this question. Would it be possible, however improbable, that a catastrophic event within the Milky Way galaxy could emit enough energy to do the same thing. For instance, if I was observing a nearby white dwarf star with my telescope and it happened to undergo a Type 1a supernova while I was watching, would my eyesight be at risk? Thank you for your fine podcast. It's a fine line podcast. I think that's more accurate. Steve from British Columbia, and he says, P.S. Andrew might consider naming the book The Terranean Trilemma. Interesting, Steve. I haven't gone with that, but you got it half right. But we'll get to that later.
It's got the.
He got two words right, actually.
That's good.
It's the Terranean something. We'll tell you in a minute.
Oh, I love it.
Yeah.
Well done. Well done, Steve.
Yeah, interesting question. I suspect not, because a Type 1a supernova, when we finally see it, would have happened a long time ago, and I imagine the energy would have been dispersed rather rapidly and widely, and by the time if you just happened to be looking at one at the right moment, that its light hit Earth, would it couldn't be damaging, could it, or could it?
Okay, put it this way, Andrew. Remember that a Type 1a supernova can outshine its entire host galaxy.
Yes.
So it's brighter than the rest of the galaxy. And if it's sitting in the galaxy and you're looking at it, yes, you're going to be blind.
Wow.
Because there will be so much energy in it. We've seen, the most recent naked eye supernova was actually in the Large Magellanic Cloud, which is 165,000 light years away, if I remember rightly. And that was it looked like a bright star. But if you imagine that was only 1,000 light years away, and that was actually not what's called a Type 1a supernova, which, exactly as Steve says, involves white dwarfs coming to the end of their lives rather dramatically. But imagine that it was only a couple of thousand light years away or something like that. Then you've got a very high intensity radiation. We'd also feel the neutrinos and things of that sort that would come from it. So it wouldn't just be your eyes that you'd have to worry about.
But that sucks. I mean, you are born 1,000 years or however long after this thing, did the dirty on itself, and then you pay the price. That's just wrong.
So it's part of the deal.
Yeah.
Just to carry on from that. Probably the most likely object to turn into a supernova in our galaxy at the moment is the star Betelgeuse, or Betelgeuse, however you want to pronounce it.
We talked about that a long, long time ago, and everyone's sort of on standby for this, aren't they?
Well, that's right. In fact, it's a bit more recent than that, because in the last few months, the last half year or so, it's dimmed to only 40% of its brightness. Now, it is a variable star. But it's also a very big and bloated object. If it was where the sun is, Mars would be inside it. So it gives you an idea of how big it is. A red supergiant. But it is actually, it's at risk of exploding.
And Steve, there's something to keep your eye on.
It may be. Steve might have to wait a long time, because we think it's sometime within the next 100,000 years when it's going to go off. But what I was going to say was, people have calculated this. It's not a Type 1a supernova, but it would be a supernova. It's about 750 light years away is Betelgeuse, and the calculation is that it would be about as bright as a half moon.
Wow.
So imagine the brilliance of a half moon, but concentrated in a single point. It will be easily visible during the day. And that would hurt your eyes to look at. I don't think it would make you blind, but it would certainly be a challenge to look at that through an 8-inch telescope, which is what Steve was talking about.
This is why telescopes only let you look through one eye, because if it does happen,
so you've still got
the other one.
Yeah, except some people do it through binoculars, Andrew.
Yes, they do, don't they? Yeah. Okay, so the answer is yes.
Yeah, it's a great question.
It would hurt. It would hurt a lot, Steve. Okay, thanks for your question, and thanks for getting in touch, and thanks for the suggestion for the book title. Moving on, we've got a question from Frank Marika. I think that's how it's pronounced. Hi, Andrew Dunkley. I wonder why he's gone full name on me. I'm wondering, you tell us about stars and planets, you talk about how they have gravity, but you've never taken a moment to tell us why and how they're able to have such a force. Could you help me understand that, please? I'm watching this documentary about how a collision between Theia and something else led to the formation of the Earth and the Moon. How and why do they have gravity? Where did it come from, or where did they get it from? And you've always said the Moon is moving away from Earth. Does this mean the ocean tides are going to fade? P.S. I'm really wondering about this stuff. Please tell me about them, Frank Marika. Yeah, he's full of wonder, is Fred. It is Frank, Fred, and I don't disagree with him. These are the sorts of mysteries that we like to discuss, but some of them are not easy to grasp. Gravity is one of those elements that we struggle with to a certain degree.
Well, you're right. Both you and Frank are absolutely right, Andrew, that we really,
well, that's a first for both of us.
Well, it might not be a first for Frank, but it is for you. Even the physicists struggle to know what causes gravity. Frank's question is, how and why do they have gravity? Where did they get it from?
And the answer, always, from my childhood, because.
Yep. It's because, that's right. But the because doesn't have anything coming after it. So we understand the properties of gravity. We can see how gravity behaves, and that's the theory we have at the moment, which originated with Albert Einstein in 1915, the general theory of relativity. That perfectly describes the way gravity acts as a distortion of the space around massive objects. And in fact, it extends to the distortion of space around any object. You and I, to a very slight extent, because we're made of matter, we distort the space around us, so we have gravity. But it's, that at the level of a human body, it's not something that we can really measure. So we could couch this in a different way. The astrophysicists, starting with Einstein, have shown us the way gravity behaves, and that collision between Theia and the proto-Earth back in the very early days of the solar system that Frank mentions, that clearly was dictated by the gravitational pull between them. So, as I said, the astronomy defines how gravity behaves, but what the physicists look for is a way of treating that in the subatomic world, because we know that nature has these fundamental forces, 4 of them, in fact. The strong and weak nuclear forces. There are 2 separate forces that interact between subatomic particles. And then there's the electromagnetic force, which is magnetism and light. And that's what actually makes chemical reactions happen, because it's all about electrons. And finally, there's the gravitational force. Now, that is the least understood of them, and it's also by far the weakest. It's billions and billions of times weaker than the others. And that perhaps is giving us a clue as to what it's all about. Maybe it's weak because it leaks out into other universes or something like that. But what I was going to say was the particle physicists have got very accurate and workable, practical, and so far, completely reliable theories about how these forces are transmitted by particles. So the strong and weak nuclear forces have particles. There's the gluon that carries the strong force, something called the W and Z bosons that carry the weak force. The photon carries the electromagnetic force. And so people would very much like to know about something they call the graviton, which is the particle that carries gravity. But at the moment, we have no quantum theory of gravity. And so gravitons are really still a figment of people's imagination. They're probably there, but we have no theory to understand them. And it's only when we get to that step will we be able to answer the questions that Frank raises, because he's right. We can understand it as a phenomenon, but we don't really know where it comes from. That's gravity.
Yeah. So the answer, Frank, is dunno.
There's one bit of Frank's question that we do know about. It's his last bit. You've always said the moon is moving away from the Earth. Does this mean that the ocean tides are going to fade? Yes, it does. Over very long
next week, by the way. Next week it'll happen.
Don't listen to him, Frank. He's raving. It's actually the week after. It's measured in tens of billions of years, so it's not anything to worry about because the Earth will have been fried before then. But yes, as the moon moves farther away, the Earth's rotation slows down. Eventually, the Earth and the moon wind up facing one another. The moon goes around once in, I think it's 47 days. The Earth goes around once in 47 days, and so there are still tides, but they're only coming from the sun rather than from the moon. So they're only about a quarter as much as what we have now.
Fascinating. Thank you, Frank. Appreciate your question. Hope we adequately answered some of those questions. I think we did. Now, Fred,
the big reveal.
I guess we should do the big reveal. And thanks to everybody who pitched ideas for book titles. I got some real rippers. Actually, if I do some hunting around, I might be able to find a couple. I should have thought about that before, but I didn't. But let's see. Got a few here that people came up with. Yes, how about the triple cross? That came from Peter Scott, or triple jeopardy was an idea for the title. That sort of fits, but I wanted something a little bit more technical, I suppose. We've got the seventh sun, because there were 7 fleets leaving 7 worlds. So that was a thought from Petrus. And I've got a whole bunch more. Hannah, I think, might have come up with an idea. No, that was someone else. I'm just ad hocing here. Brian has come up with dozens of ideas. Exodus, entanglement, interstellar tripartite pact, a journey's end collision, the Borsch, etc., etc. Look, I'll put you out of your misery. I read them all. I thought about them. I nutted out ideas. I started sort of doing some deep and meaningful homework on what I wanted, and I came up with the Terranean enigma. So it will be cool. You like that?
Ooh, I do like that, yeah.
Yeah, the Terranean enigma, which could mean a lot of things. Look, that's where we're at so far. I just today finished the book, the back cover blurb. You know, when you write the sort of what's going on type of thing that's supposed to hook someone into wanting to read your book. Do you mind if I read it?
Oh, no, go for it, Andrew. Let's hear it.
It'll only take me 20 minutes. When the Borsch invaded the 7 worlds of the Andromeda Galaxy, the people fought hard to defend their colonies, but they were confronted by a disciplined and unwavering foe. The Borsch proved overwhelming and without mercy, killing indiscriminately, their goal, extermination and slavery. When it was realised that the war was lost, 7 fleets were quickly launched to 7 points in the universe identified as having habitable worlds. Each fleet carried experimental jump drive technology that would enable them to travel vast distances in a very short time. The reliability of the neutron-powered drive was in doubt, but there was no choice. They had to flee. The first Andromedan fleet, under the command of Admiral Kalu Vadan, left its home world with a select crew and many thousands of military personnel and civilians on a quest to settle on one of these new worlds in a place far away from the Borsch. During their final jump, a cataclysmic failure saw the fleet scattered with many ships lost. Only the Admiral's ship, the ISS Titania, arrived at the new world, severely damaged. The planet Terranea was beautiful, a watery blue ball with a single grey moon, warmed by a medium-sized yellow star. Sound familiar? But to the horror of the Andromedans, it was already occupied. Without anywhere else to go, they had to decide to either negotiate asylum or just take what they needed from the people of this world, just like the Borscht had taken from them? Or would something else jeopardize their hopes for the future? There it is.
Ooh, yes.
So that's where we're at, the Terranean enigma.
Yeah.
So have a think about that. I'm just sort of finalising a few bits and pieces. I've got my brother getting ready to do the final cover, and then it will all be uploaded, and hopefully in the next month or so it will be published for your consumption. It won't be a big book. It's only a bit over 100 pages, which is a short story in the scheme of things, but I wanted it that way. I don't want to get it complicated with too much mumbo jumbo. I just wanted to tell the story, so I kept it tidy, I think was the way to describe it. So look out for that.
Mumbo jumbo is the stock in trade of space nuts, Andrew. I'm surprised you didn't want to.
Maybe I've used it all up on the podcast.
Quite so.
But nevertheless, we will definitely let you know when that's out, and it'll be on the Space Nuts shop, which you can find at bytes.com/spacenuts. And there's another couple of books in there as well if you want to peruse them. Someone the other day messaged us on Facebook, Fred, and said, you need to put the link for the Space Nuts shop on. So I did, and then he wrote back to me and said, I bought a T-shirt. Which is lovely.
Good on him.
Yeah, so that's where it is, bytes.com/spacenuts. Thanks again to everybody. I will give you a collective credit in the cover because everybody contributed and tried hard, and I appreciate that. I think my failing was I probably should have told you that much before, but I hadn't written it at that point. But nevertheless, I appreciate the effort, and I appreciate you putting in a great effort too, Fred, mini moons and all.
Well, it's a pleasure. I'm the master of mumbo jumbo, and I will continue to be so, I hope, on Space Nuts for many millennia to come.
Or minutes, whatever comes first.
Or minutes, yeah. All
right.
I don't care.
We'll catch you next time, Fred. Thank you.
Sounds great. See you later.
Bye. Professor Fred Watson, Astronomer-at-Large, and from me, Andrew Dunkley, thanks again for listening. We'll catch you next week.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.